Good morning all. I'm going to continue my video lecture series based on database management system. My topic is B tree. In this we are having an tree multi-level disk indexing. B tree index is a multi-level index. B tree is a rooted tree satisfying the following properties. All paths from the root to leaf are equally long. Okay. A node that it is not a root or leaf has between n by 2 and n children is happened. A leaf node has between n minus 1 divided by 2 and n minus 2 values. Okay. Now here the structure of leaf and non-leaf node of this tree is if P1 is Pn minus 1, if K1 is Kn minus 1, if P2 if Pn, if you are having up to P1 to Pn. Okay, this is the property of B tree. Following the non-leaf node number of keys is 1 less than the number of its children. The number of key in the root range from the 1 to m minus 1 maximum. The key range from minimum m by 2 minus 1 to max m minus 1 for all nodes, non-leaf nodes besides the roots. Thus they can have between m and m minus 2 children. The level of each leaf node is the same. We are having an algorithm here in simply search tree, insertion, deletion. Search is an big O. For search, insert, delete. All time complexity is big O of log n only. We are having an example here 10. They are having a tree here. Now step 1 is first search will start with root node. Root node is an 100. Okay. Step 2 is then it will check in the range the key that is having 120 is greater than 100 or greater than less than 130. Okay, if you have to check here, so the jump from the 100 to 130 and 180. Okay, it has been left branch of the B tree. And then now as a given as 120 is greater than 130, less than as 130, so it has to be a rightmost child node of the current parent. Okay, 130 is less than 110 and 120, so it gets from the left side of the parent node. Okay, and then 130 to 180 in between, 140 and 160 is an in between, so it has taken up with the in between child node. After 180, 190, 240, 260 is an after 180, so it is taken up with the higher order number, so it taken with the right side of the 180. Okay, so it will jump will be happen from 110 to 120. And then step, if you are having another step, if the another values contains in between to 110 to 120, it will be happen in the center of the parent node. Okay, and then if you are having an values from 10 to 20, that 15 means if you are the leaf node, the child node will be happen in the in between of 10 and 20. If the values get from 10 less than 10 means it will be the left, the children node will be the left side of the parent node. Okay, if they having values from 20 to 40, if they 25 like 30, the 20 parent node will be from the right side of the 20, it will be showing the 30, 25 likewise. Okay, this is the B tree. If you are having an rules here, for example, if you are having 100 as a leaf node, okay, less than 100 is will be an left node of left child node. Okay, if the greater than 100 means it is an right child node. Okay, if the 35 contains 35, if you get an value 10 and 20, 10 and 20 is less than 35, so it will be contained in the left side of the 35 node parent node. If the 65 compare 70, 80, 90 are above 65. Okay, greater than 65, so it will be contained in the right side of the leaf parent node. And then 40 and 50 is in between with 35 to 65, so it will be in the in between child node. Likewise here 130 and 180, 110 and 120 is an less than 130, so it will be contains at left node. 180 is in 190, 240, 260 are greater than 180, so it will get contains from the after 180. Now the 140 and 160 is in between values, so now the centralized child node will be happened here. That's all. This is an B tree. Thank you.